Okay, we have talked about the shape of a distribution, the shape of a histogram. Now we're going to talk about the center. And we have several different measures of center. The ones you know from 8th grade, mean, median, and mode. These are all measures of typical, average, different versions of averages. And you probably know what most of these are. Mode, again, in 8th grade you were told was most common, but that's not what we use here. Now we say mode is the bump in a histogram. So here's our histogram. I would say the mode is, this bump here from 60 to 90. You might say, no, I just want to say it's from 70 to 80. We're both right. We just all agree that it's around here. The median is the data point, the datum, that's literally in the middle. So we list all of our data points out numerically. We have 21 of them. We have an odd number of data points. Remember, n equals sample size. N is our sample size. That's one of our first terms. Make sure you write that down. N here is 21. So if I want to split those in half, I would want 10 on one side, 10 on the other, and I would have one left over. So I've got 10 below 73 and 10 above 73. I'm able to do that and have this one left over because I had an odd number to begin with. If I had had an even number, if this 73 didn't exist, then I would take the two guys in the middle, the 72 and the 75, and just find their average. So here I do have an odd number. The one in the middle that's physically in the middle is 73. That's my median. Next, we have what we call the sample mean. This is the average that you learned in 7th grade. So here's a bunch of mathy notation. This symbol, write this down in your notes. Sample mean is the symbol X bar. That's X with a little bar on top of it. And that's how we pronounce that. We call that X bar. And that will always mean the sample mean. This letter here is the Greek letter sigma. That means sum. X is our data points. N is our sample size. So this formula here is exactly what you already know to do. Add them all up and divide by the number you have. You should try this on your own, but if you add these all up and divide by 21, you get 69.33. Notice here that that mean is smaller than the median. It's to the left of the median. That's because we have skewed data. This guy down here that got a 5 on this test messed up the average. That 5 had a much larger effect on the mean than it did the median. That really drug the mean down. The median is the data point that's physically in the middle. If we were to cut this histogram in half by area, we would find the median. The mean is the balancing point. Imagine if this were like a teeter-totter and we needed to find a pivot point where this whole thing would balance on one single point. That's what the mean would do. It would be about right here. And this guy way out here, yes, he was small. It was only one data point, but it was really far away. So if you think about a teeter-totter, if you're really far away, that we call this torque, your force has more of an impact. So this guy here can balance out a bunch of stuff over here. So he drags the mean down. He threw off the average, that guy right there. Okay, so outliers, things that are far away from the rest of the group, have a larger effect on the mean than on the median. In a symmetric distribution, if somebody says, hey, how'd your class do? I would probably just tell them the mean. It's the better measure of center. But in a skewed distribution, the median is the better measure of center. The classic example of this is income inequality in the US. Income inequality is very skewed right. It looks like this. You get a few people in the US that are making millions of dollars a year. And if we calculate the mean income It looks much higher than what the typical person makes. That's why we typically give the median income, because that's more representative of what the average person or typical person makes.